Well, good day to you, E-Techians. Today we're going to answer the question, what is power? And how is it related to energy? Because they're different things. A lot of people use the word power when they mean energy, or they use the word energy when they mean power. So in science, we got to be really careful with our words. So we're going to define power very precisely today. We'll do a review of energy transfer, because power involves the transfer of energy. In order to do today's activity, we need to learn about unit conversions, how to convert pounds into newtons and newtons into pounds. They're both units of force. We'll talk a little bit about unit conversions. Then we'll define power, and we'll come up with a formula for power. So we'll add that to our formula list. I'll do an example problem involving power. It'll be very similar to the lab activity, the power lab that we're going to do, where you're going to get to go outside and saunter or scamper or sprint up the stairs, and we'll see how powerful you are in doing that. So let us begin. Let's remember what we mean by energy transfers. By energy transfer, this is when we're moving energy from one system into another system. Like something has energy. There's gasoline in the tank of your car. You want to turn that chemical potential energy into the kinetic energy of your moving car. So that energy has to be transferred. And we talked about several ways of transferring energy. One of them, which we're not going to use today, is heating. And heating involves when you have, a hot object, so that is some object at high temperature, and we put it near an object that is cold, and this just means that the thermal energy in this guy is going to flow or transfer into the lack of thermal energy over here. And this is like when you put an ice cube into a cup of hot water. Thermal energy will be transferred from the heat, from the high temperature surroundings into the cold ice cube. And we're going to talk a lot about that later on. Then we also talked about waves, and there are different kinds of waves. We talked about electromagnetic waves. I'll just say E&M. Okay, we talked about sound. Sound is a way of transferring energy through material, through a gas or a solid or a liquid. And then and then there's lots of other kinds, like if I'm sending a wave through a rope or a slinky or something like that, or any kind of material, I'm transferring energy from one place to another. And we are going to talk about waves. But and then another way of transferring energy we're not going to use today is electricity. And that's when we transfer energy through the application of force onto electrons moving in a wire. So when electrons are being pushed through a wire, they can transfer energy. And we're going to study that, I think, in the next unit, actually, when we're done with this. But one of the main ways we transfer energy, and the way we're going to do it today, is through work. And work is when we transfer energy by using a force. Force is used. Okay, and this is, and actually what you're going to do today is you're going to run up a flight of stairs. So here's a flight of stairs. So let's say the top's over here, and you're going to start right here. Okay, this is not drawn to scale, but you're going to run up the stairs. And how are you going to do that? You're going to apply a force to the ground, and the ground's going to apply a force to you, and we're going to use force to transfer energy from the chemical potential energy in your legs, and it's going to turn into your gravitational potential energy up at the top of the stairs. So here you are, all triumphant at the top of the stairs. Now, so again, energy is transferred when a force is applied through a distance. And remember, so we had a formula for that. Work is equal to force times distance. And recall that this was measured in newtons. This was measured in meters. A newton times a meter was defined to be a joule, which we used a capital J to represent. And this is what we need to know in order to talk about power. Before we get to that, let's take a look at this this force in newtons. When you run up the stairs, and that's what we're going to do, we're going to run up a flight of stairs, the force you have to apply is the force that's equal to your weight, right? Because gravity is pulling you down with your weight. The force of gravity is pulling you down. And that means you have to push up against your weight in order to move up the stairs, right? Well, you're used to your weight being measured in pounds. And so the force of gravity, like my weight right now, is 220 pounds. Okay, and I would like to reduce that weight, but unfortunately that's where I'm at right now. 220 pounds. But this is not usable to us if we're going to measure how much work it takes to climb a flight of stairs. We have to convert this to newtons. So what I want to do right now is show you how to convert from pounds into newtons. And I think in Mr. Kinney's class you've already done this, but in any case, whatever. So it turns out that if you have 1 pound of force, if you're applying 1 pound, that is the equivalent of or equal to applying 4.45 newtons. If you want to use 4.5, that's okay, it saves a little bit, but 4.45 newtons. So 1 pound of force is 4.45 newtons. So you can see that a newton is a smaller measure of a force than a pound is. All right, so what I'm going to do is I'm going to convert my weight, my 220 pounds, into newtons. And so what I'm going to do is I'm going to say 220 pounds, and then I'm going to say, well, I want to get rid of the pounds. So what I'm going to do is you take what you want to convert and you put it on top of a fraction where you divide it by 1, because that doesn't change anything, right? 220 pounds is the same thing as 220 pounds divided by 1. Okay, well, here's the thing, and this is a kind of an abstract idea, but it's a very useful idea. What I'm going to do is I'm going to use this conversion factor and I'm going to treat it like a fraction. Okay, and that is well, watch this. Okay, let's take this equation here. We said that 1 pound is equal to 4.45 newtons. Now I'm going to divide both sides by 1 pound. Is that okay? Sure. The rules of algebra say I can do anything I want as long as I do it to both sides of the equal sign. So I'm going to divide both sides by 1 pound. 1 pound. Okay? Does that make sense? Now, what is 1 pound divided by 1 pound? Well, what is anything divided by itself? It's 1. So 1 pound cancels 1 pound. This is equal to 1. Just 1. No units. 1 pound divided by 1 pound is equal to 1. And so we have 4.45 newtons divided by 1 pound is equal to 1. Well, here's what I'm going to do. To convert this, I'm going to multiply 220 pounds divided by 1 times 1. I can do that, right? I haven't changed anything. You can multiply anything by 1. But 1 is equal to this. Yeah, it is. So I'm going to go 220 pounds divided by 1 times, now watch this. Instead of multiplying by 1, I'm going to multiply by 1 this way, saying 4.45 newtons over 1 pound. And now, notice that the pounds, what is a pound divided by a pound? It cancels out. And the only units that's left here are newtons. So I'm going to take my trusty HP calculator that's more than a decade older than you guys. Okay, and I'm going to say 224.45 times, and that will be 979 newtons. So I weigh, lucky me, 979 newtons. Go ahead and figure out how much you weigh in newtons. Okay, and by the way, if you're embarrassed about your weight, either because it's too low or too high according to what your ideal weight would be. See, my ideal weight, I'd like to be about 190 pounds. I think I'd look good. But anyway, if you don't want it on your paper, how much you weigh, then fine, use whatever weight you feel like. But if you're kind of curious about how much you actually weigh, just put how much you weigh right here, put it over 1, put it in pounds, and multiply by this conversion factor. And put the answer right there, and because we're going to use it in today's lab. But yeah, we are going to use it, and other people are going to see it. So again, if it's none of anybody's business what your weight is, then use a different weight. Use anything you want, because I don't care. All right, now. So let's move on. Let's talk about power. So power. Now, what is power? What does it mean to be powerful? If you are powerful, that means you can do a lot of work in very little time. It's a rate. Power is the rate at which energy is transferred. Okay, power is the rate at which energy is transferred. Now, rate we mean by how much energy is transferred per unit time. So power is equal to energy transferred divided by the time it took you to transfer that energy. So if you do work by, let's say, picking up your backpack up off the floor, right? You pick your backpack up off the floor, but if you do it very slowly, you're going to transfer energy into the backpack. You're giving it gravitational potential energy, right? But it's taking a lot of time to do that. So your denominator here is going to be really big, and the power is going to be pretty small. So let's write this with this now as a formula. Okay, now the energy transferred, what we're going to do today is the energy transfer that we're going to talk about today is work. We're going to do work. So it's work over time. Okay, today. Now, later on when we're talking about electricity, right, we're going to have electrons, so it's going to be the energy transferred by electricity or whatever. So, but today we're going to be doing work. So power for today is work over time. And work is a way of transferring energy over time. Oh, so power equals work over time. We use a lowercase t for time, capital W for power. So we've added two new variables that we can put on our quantity chart that we made the other day. So this is the formula for power. Now let's talk about units. This has units of, work has units of joules, and time has units of seconds in the metric system. This is the standard kind of units we're going to use. Joules per second is used a lot, and what do you think we should call it? Anybody? What do you think we should call a joule per second? That's exactly right. We're going to call them watts. So a joule per second Yeah, I've been waiting all year to tell that joke. A joule per second is equal, we call that a watt. Not a what, but a watt. W-A-T-T, named after a physicist named Watt. Okay, so I don't know what he discovered, but anyway, all right, it's a watt. Now we abbreviate a watt with a capital W, right? Which is unfortunate because we also use a capital W to represent work, but this right here is not a unit. This is a variable name for work. When you see a W next to a number, that is, it's being used as a unit, it stands for a watt. Okay, so we have our formula. Power equals work over time. Let's let's do an example problem. Okay, suppose that suppose we've got Sally. We'll just call her Sally. Sally weighs 100 pounds and is Sally weighs 100 pounds and climbs a 3-meter high ladder in 20 seconds. How much power did she put out? Okay. So this is our example problem. Let's use the given find and solve format to solve this problem. And it's a little tricky because we got to make a unit conversion. So we'll say given. Well, let's draw a little ladder. So here's a little ladder. And it has a height of, well, I'll call it a distance for now. There's the distance that she's going to climb. You can call it height if you want to. But you'll see why I'm going to use the word distance. So here's Sally. She's got her hands on and she's going to climb this ladder. Okay, now her weight, or the force, remember weight is a force of gravity. Force of gravity is 100 pounds. Okay, and the time it takes her to climb this ladder is 20 seconds. So she's really taking her time. Okay, so this is what's given. Okay, now let's find, what are we trying to find? We're trying to find power. Okay, and well, let's solve it. Now this is a little bit more complicated than the problems that we just went over, because we got to do a couple of things here before we can figure out what power Sally has to use to climb this ladder. But let's start with the formula for power, since that's what we're trying to find. Power equals work over time, right? Power equals work over time. Now, do we know how much time it took? Yes, it took 20 seconds. Was how much work it took to climb these stairs given? No, it was not. So we don't know how much work it took to climb this ladder. We're going to have to figure it out. But we do have a formula for work, don't we? What is the formula for work? Anybody? Anybody? Say it. Just say it out loud. What's the formula for work? That's right. Work equals force times distance. And in this case, the force is the force of gravity. 100 pounds. Wait a minute. 100 pounds. I can't multiply, oh, I forgot to put, the distance is 3 meters over here, sorry. I can't multiply a meter times a pound because that won't get me a joule. So what do I have to do? I'm going to have to take these pounds and convert them into newtons. So I'm just do that up here. 100 pounds. Put that over 1. And we have our unit conversion factor. 1 pound is equal to 4.45 newtons. Well, do you need a calculator for this? If you do, would you smack yourself across the face? You don't need a calculator for this. Whenever you multiply by 100, you just move the decimal over twice. I mean, I don't want to get violent here, but come on, people. You don't need a calculator for everything. So this is our force. This is the force. She has to lift her weight, and her weight now in newtons is 445 newtons. She's got to lift that weight up the ladder. So now we have our force is 445 newtons, and our height is really just like the distance we're going to pull that weight up, and we said that that's 3 meters. Now you can use a calculator to do this. I'm going to try not to. What's a newton times a meter? That's a joule. And then 3 times 5 is 15. 3 times 4 is 12. 13. So 1,335 joules. That's how much work it took for her to climb the ladder. Really, that's her gain in gravitational potential energy, too, if you want to think of it that way. But are we done? I mean, what are we trying to find here? We're trying to find power. So we're not done. Well, now we can plug it into this formula. The work is 1,335 joules divided by 20 seconds. See, because now we know what the time is. And I'll go ahead and use my calculator for this, although it's fairly easy arithmetic. So 1,335 divided by 20. And you get 66.75. I'll round that off to 66.8. 66.8. 66.8 what? Right! 68 watts. I meant watts. A joule per second is a watt. So the power is equal to 66.8 watts. So that's how much power, that's the rate at which she had to put out energy to climb that ladder. Now, one thing before we get to the lab, she actually puts out more power than this to climb the ladder, because much of her energy, when you exercise, most of your body's chemical potential energy gets transferred into heat, right? Because you warm your body up, you warm up the air, and so on. But this is the rate at which she's gaining gravitational potential energy as she climbs that ladder. And that's really what we're going to measure today. So let's get to the lab. Now there's 3 or 4 people in your group. So here's what I would like you to do. I want you to make a table. And in your table, I want you to put the name of the person in your group. And then, let's see, I want you to put your weight in newtons here. And then we're going to climb the stairs, and I want you to measure the time it takes to climb the stairs in seconds. Now, what stairs are we going to use? We're going to use the stairs at this on the main building. So some of you will go on the west side, some of you will go in the middle. We'll break up into 2 groups. But here's what's happening with the stairs. You have some stairs like this, right? When you go up the stairs in the main building, and then you have like a landing kind of a thing, and then the stairs continue on up the other side, right? and then you're up here by by the main building, and you now really what we care about is this distance here. That's the distance that you're going to climb. Okay, now what about this horizontal distance? Don't worry about it. It doesn't take any work against gravity to go horizontally. Okay, we'll talk more about that later. Just take it from me. All you need is to know what distance up you're going to apply your weight. Okay, and oh shoot, I forgot a column for power over here. So add a column. This is when you're going to figure out how much power you have. Each person has. Okay, I'm not doing this very well, am I? What do you want? It's free, right? Free education. You get what you pay for. All right. So anyway, there we go. And so what I want you to do, here's what you can do. How are you going to figure out this distance right here? How high the stairs are to go all the way up here and here? Well, what you're going to do is you're going to measure one stair. So use a metric ruler and measure this, and then count how many stairs there are and multiply. And it is in centimeters, right? You know how to convert from centimeters to meters, right? There's 100 centimeters in 1 meter. Do the unit conversion. I think you can do that. It's roughly about 4 meters, but I want you to get it to the nearest centimeter. Okay, so figure out what the distance is to the top. And then what you're going to have to do is I want you, like a group of you, to be all gathered down here, and then have somebody standing on the landing. So here's our timer, and they're going to use a cell phone, and they're going to say to you standing in line down here, to this person, they're going to say go, and I want you to race up the stairs, and this person will tell you what your time is, and then you can add it to your data table here. Now, if you're wearing shoes that make running very difficult, then just walk fast. Or if you want to see how powerful you can be, sprint as fast as you can, but don't be crazy, okay? Don't hurt yourself. And sprint up the stairs and time how long it took. Okay, and then what you're going to do is you're going to figure out your power. You're going to figure out how much work it took, which is the force of gravity, your weight, really that's really force of gravity right there. Take your weight in newtons, multiply it by this height, this distance that you apply your weight through as you climb to the top of the stairs, and divide it by time. And again, this has to be in newtons, this has to be in meters, and this has to be in seconds, because a newton times a meter is a joule divided by a second is a watt, and I want the answer in watts. So put power in watts in your data table here, and I want you to show your calculations for everybody. So go ahead and get yourself ready, and we'll go do the lab. Okay, if there's any questions, you can't ask me right now because I'm at home, but when you watch this, I or Mr. Kinney will be there for you. So see you then.